Hello, everybody. My name is Anton, and I'm a software developer at SIG. Today, I'm going to talk about microservices in Go. I'm going to compare different frameworks. Just a couple words before I start. I'm not everyday Golang developer. I do it for my hobby. So from day to day, mostly Node.js developer and AWS infrastructure developer. So the practical example I will show at the last part of the presentation. Don't expect so much like crazy stuff there. Other than that, just thanks for coming. Let's start. Just a couple definitions of what microservices are. So microservices is an architectural style that structures an application as a collection of loosely coupled services which implement business capabilities. This is the definition you can find at microservices.io resource. It's very useful resource if you want to read about architecture. It's targeted mostly to the architecture patterns rather than implementation in different tools or technologies. A couple more definitions of microservices. So microservices software that fits in your head, or microservices implements a single bounded context. Microservices built and deployed independently, which is stateless and state-based services. So that the last definition is provided from 12-factor application. So again, the other resource which is very useful. This resource is supported by the guys from Heroku, and they post there the best practices. So I highly recommend to go there and read it. And microservices also should be addressable through a service discovery system. So why I talk about it, that the next frameworks I will be discussing, they more or less support all these statements. So why do you want to implement microservices? So they provide smaller, simpler applications which are easier to support, and it's easier to scale the applications itself, like a horizontal scaling, or it's easier to scale the development of applications itself, because you can have a huge team of developers. You can split it into smaller teams and dedicate each team to develop of every microservice. Also, it provides improved fault tolerance and isolation, and it also eliminates long-term commitment to single technology stack. This is what almost every software developer don't like to do, so that as soon as we're stuck with one technology, we cannot jump to something fancy and new. So it's also always very good to have something that you can practice and you can do some experiments with new technologies. Some negative points of microservices. You need to handle inter-process communication. You need to handle partial failures, distributed transactions, provide cross-service integration tests, and also manage development services which or features which span across multiple services. But in most of the cases, you are supported by the tools or software to tick almost all of these checkboxes. For instance, to support cross-service integration testing, you can apply packed contract testing and many other features. And usually, all the positives of microservices, they actually been the negatives. So next, why do we want to implement microservice in Golang? Because Golang is awesome language, and we're here to support it. It's statically typed, fast compiled, provides native binaries, big standard library, and it's native networking support, which is very important when you create microservices. That's the first part of discussion. It's a boring part, sorry. Now I'm going to talk about the exact frameworks and implementations of microservices in these frameworks. So probably you heard about the Go Micro, Go Kit, Kite, and Gizmo. So what is Go Micro? So Go Micro is a pluggable framework for writing microservices in Go. So out of box, you receive service discovery, load balancing, support of synchronous and asynchronous messaging, also message encoding in RPC client service. Go micro architecture, sorry. Yes, I'll talk now. So all plugins are usually spread across these 5 elements. So these two layers provided and supported by Go Micro, you actually cannot change anything there. So you can write plugins for these 5 elements. So the broker element provides you messaging broker. So by default, it supports peer-to-peer messaging and via HTTP. Codec supports encoding of the messages before it transferred on the wire, so it can be JSON based on message pack and other. Registry allows your service to self-register via service discovery system, and selector works on top of the registry and it implements the algorithm of filtering of the service. It might be random or round-robin, how the service discovery or load balancer choose what service to forward the traffic. And the last element is transport. Transport supports actually synchronous transporting. So GoKit, in difference with Go Micro, GoKit is usually a set of libraries. So it's not a framework in understanding how we understand the framework. It's just a set of tools you can build your application from. But GoKit philosophy is there is no global state, declarative composition, explicit dependencies, domain-driven design. And it also supports RPC as a primary messaging pattern. And if you look at GoKit architecture, it's just a set of bricks you can combine together to create your services. This is an example of architecture provided by the author of GoKit, Peter Bergen, on a Go Microservices conferences. So where in the middle you see business logic, it's de-attached, it doesn't depend on anything on transport layer or something like this. And it's wrapped with other layers. And GoKit provides lots of lots of libraries to choose what you want to pick for your logging, what library for logging, what library for balancing, etc., etc. The Gizmo, it's also a microservice toolkit which provides packages to put together services and pops up daemons. It supports out-of-box standardized configuration and logging, health check, configuration for managing pprof endpoints, also metrics and for endpoints and graceful shutdowns. And Gizmo consists of 5 packages. It provides you a server which is implemented with simple server or RPC server. So simple server implementation provides the ability to support HTTP, JSON communication via HTTP. RPC supports gRPC communication. It also provides an experimental package called Server Kit, and it's this package built on top of GoKit, actually. It also provides out-of-box configuration package, so it can automatically load configuration from JSON or from console key value storage. Works with PubSub, so it can work with Amazon SNS, SQS, it can work with Kafka, and also it provides you PubSub and PubSub tests, so it provides publisher and subscriber tests, and wraparound web servers and clients. And the last one is a Kite. The Kite is also a framework for developing microservices in Go. Also provides you RPC server and a client. And by default, all kites are service discoverable via the control which is also written in Kite. And because it's written in Kite and it's like works well within its ecosystem, and it requires lots of development around it, so I decided not to keep going with Kite. So for my practical example, I chose the first three frameworks. So some objective comparison of these frameworks made based on a GitHub. Almost like all of these frameworks created almost at the same time, approximately 3 years ago. The winner of the popularity is GoKit, so it has almost 10,000 stars on a GitHub. And they also very well developed. So the latest commits, you can see it like happened a couple of days ago in the GoKit, and then Go Micro. Again, ratio of open and closed issues is very good in my opinion as well. And now the subjective comparison. So my own opinion about these services or these frameworks. So what they share together. So almost all these frameworks, they don't provide good documentation out of box. The documentation you can find is usually the README on the top of catalog, on top of repository. For Go Micro, there is very good blog, which is copied to Medium account, and examples are also available in the repository. For the GoKit, there are more useful information in a Peter Borgen blog, who is the actual creator of this framework. And when I tried to implement service in Go Micro, I looked at the provided examples from repo, but I could not proceed for a long time. And I found the better examples in a RuRocker blog. And the last one, Gizmo. So the best documentation about Gizmo in the source code. So the source code actually is very well structured. So it's very easy, again, in my opinion, to pick it up and do some hack around it. About users and community, again, so Go Micro is used and sponsored by Sixt. Sixt is a car rental company which works in Europe. It has 26 contributors and 363 forks. The GoKit development supported by DigitalOcean, so it actually gives a good recommendation for GoKit. Over 100 contributors and almost 1,000 forks there. And then the main user of Gizmo is New York Times. But surprisingly, it has more contributors than Go Micro. And the last comparison is the code quality. So Go Micro doesn't provide us information about code coverage, but it has great Go report rating. GoKit has good coverage. It's almost 80% of the code coverage and excellent Go report rating. And Gizmo has almost 50% of code coverage and also has excellent Go report rating. Now let's move on to the practical example I created. So I created 3 services in each of these frameworks: Go Microservice, GoKit, and Gizmo. As soon as these services started, they self-register with console load balancer via HTTP, but inter-service communication happens via gRPC. I have service discovery and all services already running. So this is user interface for the console, so you can see all the services running on your host on the console. So now I'll try to send different requests. First request via curl. So we can actually use curl to ask console to provide us information what service is running. It provides the first request, gives you the list of all services, and then you can go to the particular information about each service. So it gives you ID of the node, it gives you the service address and service port, so that we can actually run the request against the service running on this port. And in this case, it will be request to Go Micro service. So we can also request this service via RPC. And the rest of the services work with a similar way. So if you don't mind, I'll jump to the code. We'll show how the code is structured. I'll start from Go Micro. So the service development in Go Micro starts from protobuf service definition. So first you need to do is define your protobuf service, and then you need to use a custom protobuf compiler to be able to create two files, one which contains a description of your request response, and the other one contains the description of client and service interfaces. And then you can implement these interfaces for RPC calls. So what Go Micro does, under the hood, it picks up this definition. All you need to do is just implement the interface. And you need to separately define the interface for the HTTP protocol. But under the hood, as you can see, the HTTP endpoint queries the service which running and responses via RPC. It's different to GoKit. You look at GoKit. I tried to structure the code the same way as it was presented, so that the business logic inside, so it's pure service. It doesn't have any dependencies. And then you can wrap it into middleware. So the middleware provides you the logging or any other metrics you need. And then on top of this, I created the endpoints. So this is the definition of abstract endpoints my service is going to expose. In addition to the definition of endpoints, I defined the abstract request and response. And then on top of this, I implement the exact transport protocol endpoints. So I created a HTTP handler, which exposes a health and greeting endpoints. And I defined the decoding from HTTP request response into the endpoints, which was exposed before. And I also define RPC implementation, which again depends on a protobuf definition of the service. But in this case, it's using the default protobuf compiler, which provided by Google. The Gizmo code in this case looks very much similar to GoKit. The difference is that the service looks exactly the same as the GoKit. Endpoints looks almost the same. The difference is that you need to expose Gizmo-related endpoints. And transport a bit different. Again, you need to implement the Gizmo-defined services. In terms of RPC, all you need to do is to implement the interface defined in your protobuf service definition, and it's absolutely the same as in GoKit. And the last bit is the client side. So RPC clients, so Gizmo and GoKit, they have almost the same clients. So that I'm using the default Golang gRPC client, so I'm dialing the service running on exact port and send the request to the service. The Go micro implementation is different to this because it requires you to use the Go micro defined clients, and you need to do this magic to create a new service to be able to support custom flags, command line flags, and etc. The last bit I forgot to mention is a service which allows you to register your service with service discovery system. Again, for Gizmo and GoKit, I use the default console service discovery client and API to register service. Then Go Micro does it under the hood for you. Yep.
You mentioned before that for one of the three frameworks,
yeah,
use a custom compiler to convert the protobuf files.
Yes, it's Go Micro. It is Go Micro. Yeah.
Oh, okay.
So the Go Micro, they have a fork from the Google compiler, and they needed to be able to provide these interfaces for the custom interfaces for the client and the servers. Yeah, I think that's all from code point of view. Again, I will post the PDF of the slides, and there will be links to this to the source to the GitHub of these examples and to all other resources. Let's return to the presentation and do some wrap up. So the Go Micro verdict. The service is initially created from the protobuf, and that's why you need to have the custom built protobuf compiler, which is sometimes it's not very good. And it forces you to use the service discovery, and it has, on the other hand, it has a large collection of ready-to-go plugins. So if you need to connect to AWS, SNS, or SKS, it's already there. And in my opinion, it can be a good starting point for RPC-based services. It also comes with a sidecar. Sidecar is a tool which allows you to connect the services written in the other languages or in the other frameworks. It allows to connect these tools into ecosystem of Go Micro. So the sidecar is exposed. It allows to self-register the service with service discovery system. It also works as a proxy between RPC endpoints to the other language-based service. GoKit feels like a Swiss knife for microservice creation. But it requires a good architecture skills to be able to compose a reliable service. Again, I spent maybe a couple hours on creation of Go Micro based service, and I spent several days to create GoKit because of different reasons, lack of documentation. Some examples just don't work. Also, the examples contain too much boilerplate code, and most of the code, as you could see, is just copy and paste. In case with endpoints definition, you just copy and paste almost the same code. But it could be a good start point for creation of your own framework on top of this set of libraries or generators of microservices. So good examples, again, the experimental package in GoKit, or I found Microgen, which is generator of microservices in GoKit. And Gizmo, it has a specific implementation of microservices. It was created with the New York Times needs in mind. It also provides several types of servers which support JSON over HTTP or RPC. Also supports PubSub out of box. But again, the lack of documentation and good examples can stop you. And the end word, just to wrap everything up together, in my opinion. So if you want to succeed in Go Micro, writing services in Go Micro, you need to invest more time into the Go Micro investigation itself. So you need to know the framework itself and a little bit architecture. And
I was just wondering, so in my place of work, we use microservices.
Yeah.
We don't use any of these frameworks. We basically just create little Go programs using the gRPC package prototypes, and we use Kubernetes or Docker Swarm for. What's the advantage of using these fancy frameworks?
So again, as I said, for instance, Go Micro provides you lots of plugins. For instance, if you need to connect to AWS, SNS, SKS, or to any other custom service, it might already be there, so that you don't need to write it yourself. It also provides you metrics out of box and all this stuff. So, but again, I want to finish the statement. So the Go Micro will require you to invest more time into learning how Go Micro works itself. While the Go Kit, you will need to invest more time into learning of Golang, first of all, and learning of architectural patterns in Golang. So the Go Kit asks you to use interfaces, and you can compose very, very reliable services. Plus, it has lots of libraries which will provide like histories. It provides you circuit breaker, different metrics, different logging styles. So you don't need to implement it itself. But again, in your use case, you can easily pick up any of Go Kit libraries and use it with your services. Yeah, and the last slide is just a list of references I used while I was preparing for the presentation. I think that's all for today. If you have any questions. Yep.
Let's say you're just like hacking on some code, just like want to get something into the world. What would be like the easiest thing in terms of just like producing something?
Which framework to pick up to do, or?
Which one would you use? Not necessarily like production ready or.
Yeah, I would use Go Kit.
Okay.
Yeah, because again, as I said, you'll need to invest more into Golang learning and into architectural patterns learning, which you can then reuse after that. But the knowledge of only Go Micro framework, okay, it's good, but again, it's controversial to statement, so that you don't want to stick with one technology. You want to sometimes, yeah, yes. Yep.
That flip side, that's you're going to put something live. It's going to be your flagship product. It's going to live maybe don't.
Again, I would say the Go Kit. But it's my opinion. Sorry, guys. Maybe it's because I like the Go Micro. They try to be on market like a solution for enterprise world. So provide everything out of box and maybe put somebody on a license cost, etc. Rather than I would prefer to have something open sourced where I will spend more time, but I can actually be responsible for what I'm creating, so that I pull this library, write together different libraries, log the dependencies, so log the version, and I'm sure that it works well. While with this black box style frameworks, it is always not reliable, I think. Yeah.
Most of the examples that we microservices communicating directly with each other or to clients.
Yeah.
You mentioned at the start that what sort of things can it do here?
Well, I didn't dig down, like I didn't investigate so far. Sorry. Yep.
You briefly mentioned apps
Yes.
at the start. Impact on any of these testable and
Well, it's very simple examples, so you can actually test it manually. But yeah, I assume that it's one of the tools you can use to test inter-process communication or test inter-service communication, different levels. Thank you.